On the ProtoByte library development. Again, if you don't know, ProtoByte is a creative coding library that introduces soft body dynamics and sort of kind of an easy physics integration into other more general purpose creative coding libraries like 3.js and eventually P5 and Babylon, etc. It's a Verlet system, so it's driven mostly by Verlet integration. There's some more traditional Euler integration as well, and besides the soft body dynamics, there's a lot of interactivity baked into it, and collision detection built in, and then there's it's kind of a templated system, so it's easy to sort of use the existing primitives, put them together into more composite types of forms, as well as kind of extend some of the core classes and to build your own. It's all natively written in TypeScript, and there's a bunch of build environments and development environments that support right now Node, but I'll probably look at Bun and others potentially. In this example here, we have it's kind of, I'm calling it a blob right now. It's blob geometry. If I can hit the W key, and you can kind of get a sense of what the wireframe looks like. And there's a diffusion map on there, which is gives us the image, and then the library ProtoByte does automatic bump mapping. So what I do is when the diffusion map is loaded, we automatically, we in real time generate a normal map that's used for the bump mapping. And everything that I'm telling you has tons of granular controls for the coder so that you can change the level of intensity and the color of the nodes, the color of the wireframe, support structures. There's tons of stuff. I'm kind of probably gotten a little overboard in this. You don't always see the nodes and things like that. I'm just doing this for visualization purposes. So what I wanted to do in this kind of current instance of it was, you can see that you can drag individual nodes. So there's 3 levels of control. You can kind of use general world rotation. This is leveraging the orbital controls in 3.js. You can rotate. If you click on the actual mesh but not the nodes, you can kind of move this and rotate the actual geometry, and then you can actually highlight and grab any node and pull the nodes out. And you notice when I pull the nodes out and let go, the system just automatically propagates the deformation, in a sense, through the thing, because the whole thing's attached as a kind of a Verlet system. So the Verlet nodes are connected to Verlet sticks, and then there's also different types of fixed sticks. And everything I'm telling you, you can control the individual constraints and on these sticks and even some of the nodes to lock things in place. So in this example, you can see that you can, it's playful and you can kind of play with this object, but you can also use it a little bit as a modeler. So let's say, for instance, you want to sort of lock some of these deformations. You can hit the capital L key for lock, and then if I drag these out now, you'll notice that they stay in place. And so I can use this sort of as an interactive modeler in a sense. Just do a few more here. And then if I hit the S again, if I hit the L again, you'll see it'll just kind of return original form. But there's another state. Let's do that again. Command L for the capital L, and then, or say Shift L, sorry. Just kind of do a little bit more modeling here. And let's say I kind of want to, instead of like having to go back to the form, I want to save it. Well, I can hit the Shift S for save. When I hit Shift F for save, the form has actually been sculpted now. This is going to maintain this kind of structure. So the internal structure has been reformatted, as well as the external mesh. And you can see that you can still interact with it, but it'll go back to this form now, as it did with the orb form previously. But again, you can do the same thing. You can hit the Shift L again and use this as a base shape, and you can continue to kind of do further, modeling on this thing, pulling things out. You can always hit W and kind of see the mesh if that helps you. And then if I hit L again, it'll go back to that previous form. If I hit S, so do a couple more things here, you can see this just keeps scaling up. If I hit S again, then if I move a node, you'll notice it goes back. This is the new default form. And if for some reason you want to go back, you're just not happy with where this is going, right? You can always hit the capital R for reset. I'll do it in a second. So let me lock it, drag a couple more out. Okay. And then I can hit R, and it goes back to its original form. So the cool thing is that everything I'm showing you will be default behavior for everything that's built inside of ProtoByte, right? So if you use the library and you're creating a generative project or an NFT project or whatever you're doing with it, all this stuff is built in. You don't have to worry about adding any of this or programming this, and it's going to be a very simple interface to kind of implement it. And again, there's tremendous granular control. Like you control literally the amount, the size of this deformation in terms of the radial kind of how much you're grabbing and the intensity of it and the fall off as well, so that as you start dragging, it doesn't drag the whole thing with it. So there's just, crazy granularity because I'm a bit obsessed, even down to like even these node types and the color and opacity, et cetera, of these. So anyway, I'm going to be doing more periodic updates on this, and I hope my hope is to release this in 2025 in some kind of pre-alpha probably for people to start using, and it's going to be open source and free to use. And I'll be creating my own sort of generative art projects with it as well, periodically, specifically as I hit certain milestones with the library. Thanks for watching.